itself now. All right. Shortcut time. Yes. All right. First shortcut. The derivative of a constant is 0. So, where's the proof? It's right here. If I do my derivative formula, I just end up with the limit as h approaches 0 of c minus c over h, which just comes out to 0, right? Should you memorize this? Yes. Second shortcut. The derivative of x is 1. Let's prove it. How do we prove it? I do the limit formula, right? What is f of x plus h going to be if f of x is just x? X plus h, right? Minus x over h. Convinced?
Yes.
What about anything that's written as x to some power, where x is a positive integer? The derivative is n times x to the n minus 1. Should you memorize that?
Yes.
Yes. Proof. How would we prove this one? Same way. Oh, sorry. Ooh, I'm going to do it the other way, though, because the factoring is going to be massively easier to do it that way. Just like the cubic root derivative we did in 51 was massively easier by doing it this way. This is going to be massively easier. What does that numerator look like to you? Like a difference of like perfect n's, right? How is that going to factor? Because that's what I'm about to do. I'm going to have an x minus a, and then I'll have an x, to the n minus 1 plus x to the n minus 2, hold on one second. Oh, sorry, it's going to be a times x to the n minus 1. No, hold on. That's not right either. I got it. I just have to think for 1 second. Yeah, okay. X to the n minus 1 plus a to the first x to the n minus 2 plus a squared x to the n minus 3 all the way down to x, or a to the n minus 1 times x plus a to the n. Just, well,
Proving it.
yeah, we're just proving it. We're just doing the proof. I'm not actually, we're never actually gonna do this.
Oh, okay. Do we ever need to do it on
No!
Oh, perfect. This one says not.
Shh. So those reduce. So those reduce, and now I do my direct substitution, right? So I'm going to have x to the n minus 1, or I'm sorry, a to the n minus 1 plus a to the first times a to the n minus 2 plus a to the second, a to the n minus 3, dot, 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 plus a to the n minus, that should be a 2, sorry. That should be minus 1, times x plus a to the n minus 1. Oops, and that's not supposed to be x anymore, that's an a. Okay, what do each of these end up becoming? Those are all a to the n minus 1, right?
Oh, yeah.
Right, when I multiply them together and add the exponents, those are all a to the n minus 1s.
Yeah.
How many of those do we have? We have n of them. So it's going to be n times a to the n minus 1.
Oh, yeah.
Right, when we did the perfect cube factoring, right? You have a minus b, and then you have 3 terms, right? When you do the perfects, or the difference of 2 squares, you have a minus b, and then you have 2 terms. The number of terms in the second piece is going to be the same as the degree was. What was our degree for the polynomial that we factored? N, so the conjugate should have n terms in it. That's all I'm saying. We have n a to the n minus 1s. We add them all up, and we have n times a to the n minus 1, and that's what we needed. It's just the proof. Here's what you need to do with it. If we do f of x is x to the 6th, its derivative then should be 6 x to the 5th.
Oh, 7.
And you're done. No limit, no algebra. You did it in your head. It was a 3-second problem. Right? If we have x to the 1,000, the derivative is 1,000x to the 999. The exponent moves to the coefficient, and we subtract 1 from the exponent.
Where was this? Yeah, like why was I doing?
This even gets better than this, though.
Really?
Yeah.
It gets better.
It gets better. So t to the 4th is
14.
4t to the 3rd.
Yay.
R cubed,
3r squared.
3r squared, right? But this power rule gets better because it works if n is any real number, not just a positive. It works if it's negative. It works if it's a fraction. It works if it's irrational. Any real numbered n, this rule still applies. So how do I do f of x equals 1 over x squared? I'm going to think about 1 over x squared as x to the negative 2. So
Oh, wait, yeah. Negative 2 minus 1. Oh, I'm still. I thought it was.
Shh, Emma. So
Sorry.
that's okay. So you remember from Algebra 2, we have this rule of exponents, right?
Yeah.
I use that rule of exponents to rewrite 1 over x squared as x to the negative 2. Now it's in the form I can do the power rule. The exponent, the negative 2, becomes the coefficient, and then I subtract 1 from my exponent to get my new exponent.
Oh.
Negative 2 minus 1 is negative 3. And then I rewrote it with positive exponents as my final answer. How rad is that?
Very rad. I'm feeling it.
Like, how much easier does that make life?
Like 20 times easier. I don't need 20 pages for my homework anymore.
Because because how are you going to prove it? How would you prove this?
I don't know.
Well, there you go. That's why we had to do it that way.
What if I just think it works?
All right.
I swear it works.
Cube root of x squared.
Isn't that x squared to the 1/3?
Okay. Which is x to the 2/3. I heard somebody whisper.
So then 2/3 x to the 1/3.
So we'd say that y prime is 2/3
X to the negative 1/3?
x to the negative 1/3, which is 2 over 3 cube roots of x. Does that?
Oh, yeah. Well, how did we get that? Because you have minus 2 over 3. Minus what's 2/3 minus 1?
So 2/3 minus what?
Minus 1. Because you always do minus 1. Okay.
Wait,
X 2/3. You make that's the coefficient.
Oh yeah, because minus 1 is technically minus 2 over 3.
Yeah. So that's why it's negative 1.
yeah.
Perfect.
So how come? Wait. So then when you take the 2/3 and you put it in front of the x, but then don't how did you get negative 1/3?
I subtracted 1 from 2/3. 2/3 minus 1 is negative 1/3.
Minus 1.
2/3
Okay.
minus
Okay.
Mhm.
So minus 2/3. This is not C.
Does that help?
It's not nice.
Oh, never mind. That makes a lot of sense.
And then
Yeah.
the negative 1/3.
So the negative makes it in the denominator, and the 1/3 turns into a cube root. So that's why I have the cube root of x in the denominator. So the negative put it in the denominator, and the 1/3 made it a cube root. All right, let's look at this next one. It says, find the equations of the tangent line and normal line to the curve y equals x times the square root of x at the point 1, 1. And then we're not going to illustrate by graphing these, but my first order of business is I need to write x times the square root of x so that I can use the power rule on that. What is x times the square root of x?
X to the 3rd. Oh, square root of the x squared. I'm gonna take that back.
3 over 2. X times x to the 1/2 is x to the 1st times x to the 1/2. We add exponents. 1/2 plus 1 is 3/2.
No.
Because it's like,
Bro, it's just like
S1
power-
acts as like 2 over 2,
rules,
and then you add those together.
So the derivative is
Because x1 acts as like 2 over 2.
3 over 2 x to the 1/2.
Right.
No, it's 3 over 2 x to the 1/2.
I think you really wrote it 3
Oh,
over
no.
2.
I thought you started to do it. I thought you started to do it. That's why you answer. Wait. Wait.
yes, go ahead.
I at the y1 you have the 3 over 2.
That's y prime. That's the derivative.
Okay.
Y the 1/2.
No one was
Yeah.
making fun
The
of
power
What?
the power rule is n times x to the n minus 1. So the 3 over 2 that was the exponent becomes the coefficient, and my new exponent is 1 minus the old exponent. 3 over 2 minus 1, when I make a common denominator, is 3 over 2 minus 2 over 2, 1/2. Okay, to write the tangent line then, I need the slope when x is equal to 1, so I just plug 1 into the derivative. So I have y minus 1 equals 3 over 2 x minus 1. The slope for the normal is the normal is perpendicular to the tangent. So what do we know about slopes of perpendicular lines? Opposite reciprocal, so that's just negative 2/3. So there they are.
So the normal is always perpendicular
To the tangent. Mhm.
It's, that's an N. That's for the N.
Yeah, N for normal, T for tangent.
Yeah, so there's no limits in this chapter.
Nope.
Thank God. That's like my
Wait, so
kind of
on our
chapter.
test, can we just do this?
Unless I specifically ask you to do it, the definition.
Mr. Cruz,
Is there any
hold on,
problem
somebody
with
asked us.
Let's just focus on what we're doing right now, not like worry so much about the test right now. Okay? Jacob,
Is there any questions where it won't work?
this?
Yeah.
Well, if I give you like the function defined as a graph or as
Yeah.
like a table, you know, like obviously you can't do this with a picture
Yeah.
or with a table of values. Like this is not helpful.
Okay.
But if it's like an equation, no, you can do this all the time. Next up, the constant multiple rule. So if I have a constant times a function, and when I take the derivative of that, that's the same thing as the constant times the derivative of the function. Does this look like the limit rule for constant multiples?
A little bit.
I wonder why that works the same way. Because the derivative is the same as a limit, right? So all your limit rules transfer over to your derivative rules. Let's look at a couple of examples. Say I want to do the derivative of 3x to the fourth.
Pull out the 3.
Wait, how do you get 4x?
I did the power rule on x to the fourth.
How'd you do
crazy.
it so fast?
Oh, I'm not that. Oh, how'd you get rid of the D over?
So
It's just 4.
what is hold on. Bunch of questions all at the same time. What does d over dx mean?
Derivative?
Take the derivative of this.
Is 4.
The derivative of x to the fourth is the power rule
4.
for x to the third.
Oh. I was just
How am I doing it
You're so
fast?
speedy, like I just can't keep up.
Yeah, well, I try to pause whenever I write anything down to let you process.
Wow. Okay, that makes sense. 4, right, and then just subtract.
Can I just do like one more
And
time?
minus 1.
Like a little bit slower.
Got it. No, I'm freezing.
Yeah, that's what I got the negative one, but then I was kind of
Why?
Not
confused.
how.
It should be next to 0. I think that's right.
How do I take the derivative of x to the fourth? I just use the power rule.
I forgot, where the 4 minutes one?
That's the power rule. What's the derivative of negative x?
Negative 1
0.
times x.
Wait, why? No.
Negative 1 times x is 0, which is just. Hit the one. Wait, negative 1. Wait, what is simplified?
Why not? Drop off, go
Yeah.
go step by step. Wait,
Oh,
oh,
it's
it's
one.
on the derivative of negative x.
How did I do this?
Where did because go?
Oh.
And minus 1. So 1 minus 1, 0.
totally forgot about
Oh,
that
it's
one.
1. I literally forgot about that one already.
Okay, you're out there.
I mean, my equation sheet in front of me when I'm Oh.
Oh yeah, you know that the derivative x is 1. Did they give us an equation sheet?
It's a blank sheet of paper.
Wait, what?
You get nothing for the AP exam. They give you no equations.
They do for other tests.
Oh, yeah, but Calc we got so many for bio
AP Calc,
AP Calc is mean.
yes.
Will we need to know the physics equations or
No, I would give you what you needed to start with as a physics thing.
Well, no, that,
Yeah, we had some homework examples where we did something like that. Hold on, guys, because it's still getting better here. Look at what goes. Look at this next. Look at the next rule here. The derivative of a summer difference. I can just distribute the derivative operation across a summer difference. Like I can with a limit. Exactly right. So what does that now allow me to do? I can do something like this. Which, like, what a nightmare would that be to do with the limit definition?
I think I would just give up.
Well, that's the limit as h approaches 0 of f of x plus h minus f of x over h.
Oh, that's.
Imagine having to do this f of x is x to the 8th plus 12x to the 5th minus blah, blah, blah. Imagine using the limit to try to do that. It would take, like, sheets of paper, right? This, we can do, what's the derivative of x to the 8th? Okay. Nope.
No, it's already. Oh, sorry.
60x to the 4th. Okay. Shh.
Okay, so you take the 8 and then the n minus 1 is 12 minus 16. Why did we do 12 times? 4 times 16.
That's the constant multiple, right? So the 12 comes out front because of the constant multiple rule. So I just ignore the 12 and then do the derivative.
I still have to do the math. But wait, so then when you get there, minus 6. So how come the
10 is the second 3
first, the minus 6x? Like, what do you do there?
Oh yeah, the
Why is 5 0?
Wait,
What's the very first shortcut I gave you?
derivative of constant
Derivative of constant is 0.
And the derivative of x is just 1.
And the derivative of x is just 1. And now we just clean up.
Wait, it's a plus a 0.
Wait,
Like
do you
the
have to
1
do it
or the
again?
5 becomes
No.
0.
Yeah, the 5 is simple.
It's just
Oh.
lower down. Okay.
That makes sense.
There's my final answer.
That's it?
Yeah.
Oh.
So just simplified
Just
then.
be like repeating those steps, so you have to like act like time of that. So
I don't mind this.
Put every little apostrophe.
That's
You just start repeating the steps.
I'm sorry. I there's too much going on. I missed.
No, you're like act like prime of x. Like you would ask like find that you just keep repeating the steps.
F prime of x is just the derivative of f of x.
Yes, you just
Would be like,
again.
if we said f of x is equal to this, what is f prime? It's just do the exact same thing we did here. Just means take the derivative. How nice is that, right?
This is a little bit better. We're getting there.
Okay. What if we want to find the points on the curve, y equals x to the 4th minus 6x squared plus 4, where the tangent line is horizontal?
What do you do with that?
Tangent line is horizontal means
Why is it straight line? Oh, never mind.
the slope is 0, right?
Yeah.
Okay. And what tells me about the slope?
the derivative.
The derivative. So let's start by finding the derivative. What is the derivative in this case going to be?
4x to the 3rd minus 6x.
12x.
Oh,
No, minus 12x
plus 0.
Plus 0.
Plus 0.
Plus
Well,
0.
wouldn't x be a 1? So you just drop the x.
Well, it's squared.
Yeah.
So when I subtract 1 from it,
Because 2 minus 1 is 1.
it's okay.
And then so that just doesn't leave it.
That's it.
Okay. So now what we need to do is we need to solve that when it's equal to 0.
Easiest lesson we've learned so far.
I can take a greatest common factor 4x off.
So x equals 1.
I can't factor, I would never see that.
So then you just get x.
And I apply a zero product property where I set each factor equal to 0 and solve. So I divide by 4, I get x equals 0. I add 3 and then square root both sides. And I suppose if you wanted to, then you could find the corresponding y values by plugging those back through. It asks to find the points. Where would I have to plug those x's back to?
The first part.
The original.
Wait, what would that do?
Well, it says find the points.
Oh.
So it
okay.
wants the y to go with the x.
Okay, so then you have to plug it into that.
So you have 0.
Yeah, so I'd have 0, 4.
Oh yeah.
Yeah, so
You
you
have 4. And then
And when I plug square root 3 in, I get 9 minus 18, that's negative 9, plus 4 is negative 5. And I get the same thing when I plug in the negative. I just did it quickly in my head. You just plug it through your calculator or something. Right? Like square root of 3 squared is 3, and I squared again to make it to the 4th. It's 9. Right, Emma?
she's so giddy.
So like, how did they plug it? This is just plug the x's to 0, so that's
I-
how that 0 4.
Yep. And then the same thing with the square root 3
Oh, okay.
and the negative square root 3.
So we should do a that's what it's because no, we already have the.
We already had the x's.
Okay.
Right? We found the x's, and I just plugged them into the y equals equation to get the y coordinate.
I'm gonna get to it, look at him.
Everything else is 0. You have to know what. Oh, okay.
Wait, so then how did you get the, oh, wait. Never mind.
Okay. Shh. The equation of a motion of a particle is given by s equals 2t cubed minus 5t squared plus 3t plus 4, where s is measured in centimeters and t in seconds. Find the acceleration as a function of time, and then what is the acceleration after 2 seconds?
Why can't you just plug to
Yeah, why is it particles? Why is it
Yeah, why is there so many steps?
Yeah, wait, I don't get it.
Well, what you need to remember is that the acceleration is the second derivative of position.
Oh, okay. So like you have to do it.
So let's find.
S and then you get the derivative,
So
which is
6t squared.
Oh, it's just like double.
Yeah. So let's do it once.
Yeah.
What's the derivative of position?
6t squared
Acceleration is the second derivative.
minus 10t
Pierce, you're the third
Plus
derivative of
3.
position.
and then plus 0.
I don't ever write the plus zeros, but you're welcome to do that.
Yeah,
It's not wrong.
Dude.
12t 10 and then you just plug it in. So 12.
24 minus 10 is
12. Oh, oops. I was
14.
confident. I was like 12.
And then the unit should be centimeters per second squared.
Sweet.
Can't do. Okay. So
Like, how much nicer is the work here than in the previous sections?
a
So
lot
nice.
nicer.
nicer.
Except for the fact that I get to
So.
Yeah.
other than that.
All right. Couple more. So this I've seen come up once in the question bank as something you could use to evaluate a limit problem.
Only once? Like you only.
Yeah. So I don't really know that it's going to be something the AP would expect you to have memorized or not, but I just want to point this out. This is like you can treat this like an identity. The one that's going to be valuable for you, though, is here. The derivative
Oh,
of e to the x is
you did that.
e to the x.
Basically, like you were right. I do love this lesson.
Yeah.
Said I was gonna. What are the two?
My mood got better.
Hold on, guys.
What are the two problems?
What are the two problems? What?
Like the ones that we just started.
Well, I just was. These are the last two things here.
Yeah.
This limit one,
Okay.
you can treat as an identity. I was simply saying that in the question bank, like the AP question bank that I looked through to find multiple choice problems and stuff for you, I've seen something that involved this one time in all the problems I've looked at, so I don't know that it's actually something that the AP would expect you to have at your fingertips to do anything with. But the second one, this derivative shortcut, is absolutely one that you'll use a ton. And it's just the derivative of e to the x is e to the x.
Is that, and that's just.
Specifically e to the x. The derivative of 2 to the x would not be 2 to the x. We'll talk about what it is later. Correct. If it was e to the 2x, that's something different. We'll learn how to do that later.
Okay.
If it was e squared, what would it be?
No. Oh, what?
What's the derivative of e squared?
2e squared?
No.
E squared.
No.
2e. What was the question?
No, not 2e.
That's the derivative of e squared.
Derivative of e squared.
Positive limit.
No.
E squared.
No.
That's what I said. I mean, natural log.
What?
Natural log?
No.
10.
What did Tessa, what did you say?
I said 2e.
Oh, no. Who said nothing?
Me.
That's correct.
What do you mean?
It's 0.
Wait, what?
Why? Why is the derivative of e squared 0?
Does that exist?
Because e squared is a constant.
Oh.
E is just a number. E squared is a
Was it
number.
always 0?
So it's a constant. It's 0. E to the x is a function.
0 always.
Is that a good guess?
What?
So like if it's like e to the 4th, it's still 0?
Yeah.
That's constant.
Yeah, that's a constant.
Oh, okay.
Right?
I'm so shy.
It'd be like the square root of 9. What's the derivative of the square root of 9?
So am I
0. It's just a number.
Oh, okay. I love that. Like any.
Yeah.
This is the happiest like it's the third finish the fourth line all 0.
Yes.
Can I use these like together now?
You should not.
Can I see the problem
But-
now?
So the derivative of anything without a variable is 0.
I told you
Yeah.
a lot. I'm fine with it being a lot. You just use this one.
this is
You're gonna be
next
really
week?
sweet to us.
What's up?
Next weekend it's due. Well, it's easy now.
Yes.
We need to do more, obviously. So are we
Wait,
gonna
this is this week?
Yeah.
Well, yeah, okay, but then so like,
Oh, we
are we doing it next class? It's gonna be 3 weeks from that.
What's up? I'm sorry, there's still a lot of going on. I'm having trouble focusing.
Homework is due next week.
Correct.
So, like, we're just gonna get to a point where it's like the homework is gonna be like in 5 weeks from now or something.
No?
Well, it's what ends up happening is I always want one class before something's due. So like the homework you get today and the homework you get Wednesday and the homework you got Thursday from last week will all be in Sunday's problem set. That's kind of what'll end up happening. And then whatever we do Friday, which I think is just gonna be like a review day / AP practice. Is what I'm looking at. Now you guys said you had something going on.
Yeah, there's a service.
It's a service.
Tuesday's the service day next week.
Yes.
Okay. So let's plan on the test then being Thursday next week.
Okay.
I have a Bible
That makes it more time to study. No, next Friday.
And I've already like drafted the test here.
Oh.
So like
Is it harder than the last or easier?
I think that I've structured it similarly, or there'll be like a multiple choice section and there's no calculator plus like one free response, no calculator question in there. And then a second section where you can use your calculator and has like all problems that you need to show work for.
Okay.
I think it's like similar, but I think the stuff here is easier because just like You're just like doing the derivative of stuff. And like, in general, I don't ask you to use the definition of the derivative unless you like need to do it to do the problem. Yeah, Jacob.
Are you gonna give us like a similar thing of like telling us which like test questions we should look at, or?
Yeah.
More questions is actually really helpful.
Some more what?
Like when you said like what homework questions to look at, that was like.
I felt like it should have been, because there's some of them that were like almost the same problem. It was just like, oh yeah, like, but it's the same idea. You know, it's like, okay, multiply by the conjugate, everything works out, and I do a little reduce factoring, and then boom, it's like almost the same problem.
I get to see those tests.
Yes, as soon as everyone's taken them. So I have a couple of people that are still like in the process of making them up, and I will love to give them back to you, but trying to keep everybody at the same level playing field. Tessa, what's up?
Can we do number 13?
13? Yeah, sure.
Thanks. Yeah, because it's I just forgot what you do. Yeah, because this is like a fraction.
Wasn't it just like undefined because
Oh, it's S.
constant on top,
It's S.
or just zero, right?
Right?
Okay.
That's the rule you're using.
So it'd be negative, or no, positive, or negative, oh, sorry.
So that's the algebraic rearrangement. And now you should be able to do your power rule.
Does that make it negative 6?
Mhm.
Yeah.
When you so -5 minus 1 is -6. Correct.
That's gonna be 60.
So it'd be 60 to the negative.
60s to the -6.
Sure. And probably we'd write that as a fraction. 60 over s to the 6th.
Okay.
60 over 60 over S.
Is what you'd want to probably, if it was a multiple choice question, that's surely how it would be formatted. I wouldn't mark you down for leaving with a negative exponent if it's a free response question. Nor I think would they, unless it specifically said show that this derivative is equal to this.
Yeah, this is just.
Yeah. Okay.
But multiple choice, I'd almost guarantee you that they'd put it back into a fraction.
Because you do 12 negative 12 times 5. Or negative 12 times negative 5.
So the 5 applies to the.
It's the power rule thing.
How would you do 15, Tessa?
I don't know, my computer's glitching.
We pull it off. Please.
Sure.
What?
Would you have to,
I don't even know.
is 60s
Factor it first?
Over
Not factor, but
Or foil.
foil it out first. And then you can just do it term by term. Yeah, that's exactly right.
It's not bad.
In 3-2, we'll learn how to do that problem without foiling it out.
Interesting.
Because if that was like 3a plus 1 to the 57th, that's now horrible
Yeah.
to foil out. Even to the 3rd or 4th is not pleasant.
Wouldn't it be 3a?
How about 9a squared?
Yeah, 9a squared. So plus 3a
Uh-huh. Yeah.
plus 3a plus 6a.
That's the perfect square multiplication pattern. Minus or plus 6.
Oh, I was about to ask. Did I do it right?
Yeah.
Because it's plus 1 because the 6a,
Uh-huh.
and then the a with the 1 minus 1 is just 0.
3a times 2, which is 2, this 2a, and then the 2 minus 1, this a, and then 6. Do this quick way.
Yeah.
Right.
It's how all your math teachers are doing. They're foiling so quickly in their heads.
Yeah, that's what you know.
How are we doing this one?
Do you make it? Do you like multiply it by like x to the 1/2, and then do it like that, or do you keep it at the bottom?
Just keep it as a fraction.
Oh wait, I didn't. Can you keep it? Oh, I guess.
The last one's just gonna be 0.
And then you can do the derivative
Okay.
easily from there.
That makes sense. Okay, now you make 3/2 x to the, so I can see the.
What's up?
I was just.
Again, I didn't do any calculus yet. I just did the rearranging. This is the hard part,
This is
though.
literally the hardest part.
The hard part is doing the rearranging to where the calculus is easy.
And 24 minus 10. I'm gonna see it from here.
Sure. If you're regretting your seat, you're welcome to move at any time.
No, I'm chilling.
Yeah,
It was just.
I understand.
I mean, as I was Sunday.
That's a yes then.
Not yet. I'm trying to copy this. And then for this, you just do the rule.
And then now it's set up to where you can just do the power rule. Yep.
So then, I'm gonna ask you one. So then that would be x, like, so minus 1. So that would be 1/2.
What's the coefficient?
So is it just 1/2? It's just x.
3/2?
Yeah, it's x 3/2. So when it's just, it'd be.
3/2 x to 1/2? Is that what you meant? That's what I was trying to ask. I think you're forgetting the coefficient, right?
And then, yeah, so then it'd be. So the next one would be
2x to the
to the 1, and then this one. Negative 1/2. And then plus, or no, minus. Minus 3/2.
Mhm.